we're talking about circular double list, right?
Yeah.
Circular doubly linked list. Okay, this is what we are going to do. Of course, as usual, we're going to create a class node. Okay, and this class node is called for creating any new new data, right? New node basically. So we'll have class node, and in the init we will add data, right? So to create a node, you need data. And it's going to have, okay, since it is doubly, right? So you're going to have two, like previous and the next reference, right? So self dot data equal to data, self dot next. This will have the link to the next node, and self dot pref will have data to the. So here we'll put none, right? In the when you create a new one, we'll have none here. Okay, so this is a node, and we will create a class later. Class circular doubly linked list. Okay, and this will have all our logic. Okay, and when you create, so but when you create a object, okay, whenever you create a linked list, it should have that first node reference, right? Always first node we need to have a reference, so that which will help us to traverse through the list. Okay, whether it is single or double, you need access to the first, we call it as head or first, whatever, right? So we'll create a init. Okay, and the moment object is created, there is a self or head, whatever. Okay, you want to call self dot first, maybe, yeah. Okay, this is created the moment you create an object of circular linked list, circular doubly linked list. Okay, and we will add functions like insert. Okay, so we will have insert after. Okay, then we'll have functions like insert before. Okay, insert before we call it. Okay, then we will have insert at the end, insert at the beginning, right? So we'll say def insert begin. Okay, we'll have insert end. Okay, what else? Insert is done. Then you want to have remove. Okay, so you give the data and it will remove. So we'll have remove option. Okay, and you can have display option, right, to display the outcome. Okay, okay, we'll come back to it. Okay, but before that, let's create this menu. Okay, and what you can do is, if you can say if name, or let it be menu also part of the main itself. So what? Menu. Okay. So you will say here, print type the operation you want to perform. Okay. And what we'll do is we will say something like this. So we'll say insert, okay, So we will not have like, 1, 2, 3, 4. We will ask user to enter the data, right? So we'll say insert, and we can have something like this, right? Insert data after which index, right? So insert data, then we'll say this is for after. Before, begin, end, we'll add 4. Okay, insert data at, okay, so we don't need to give for begin and end, we don't have to say index, right? Data at beginning, okay. Insert data at end, okay. Here insert after, and there should be before index, which, when do you want to insert? Okay, so this insert menu is ready. Now we'll have remove and display menu. Okay. So we will say print display print. Now see remove, you also need to know which index you want to remove. So let's put it before display. So we'll say remove index. Okay, so you have big display and we will have print quit. Okay, perfect. So this is the menu. Now, how do we read the menu from here? Okay, so of course we will make it as a infinite loop. We'll say while true. Okay, and while true, and let's say we keep printing the list by itself. Okay, so before creating while true, we'll have to create the object. Okay, so I'm going to say CDLL, CDLL equal to circular DLL. Okay, so this object is created. So now to display the list, okay, we'll say print the values in the circular linked list, doubly, right? Circular doubly linked list, okay, or something like this, okay, and then we'll call cdll dot display. Okay, this should do the trick for us. Now, yeah, okay. So this will display, and then we'll ask the user, okay, choice equal to input. What what do you want to do? What do you want to do? Okay, and okay, this is choice. And after reading this, what we'll do, we'll convert this into, we'll split this. What split does? Okay, we have not given anything, right? So if by default split will split the sentence into words, like, so if you have spaces, the spaces will be removed and each of those things will be like a list. So if I say insert space 5 add space beginning, so it will create a list of insert 5 at beginning. So it will have 4 values in the list. Okay. And user can insert anything, right? User can insert multiple data, isn't it? So what we'll do, we'll say ch.split, okay, or in fact we'll convert this into lowercase before only. Ch.lower dot split. Okay. If you want to see what happens to ch, okay, you can see ch equal to, okay, and this loop will run forever, right? So what we'll give is if ch equal to quit, we said, right? Then it should break from the loop, right? Okay, let's run this. This is in P11. Let's run P11. So these are the menu option. Okay. So what do you want to do? Let's say I say insert 5 at end. So ch equal to, oh, did we not? Yeah, see, ch. So we'll quit and restart again. Oops. When we say quit, we did say quit, right? Okay. Okay, let's try again. Insert 15 at end. So ch equal to insert 15 at end, right? All of these are red. Now what do you want to do? I want to quit. Oh, ch is a list, right? So, so ch of 0 you have to say. So now you say, what do you want to do? I want to quit. Now it is quit, right? Okay. So, okay, and user might enter some spaces, right? So we can do even what do you call? We can remove the spaces. So how do you remove the spaces? By doing a strip, we can remove the spaces, right? So strip we can do before even doing lower or after lower, okay? Doesn't matter. Split has to be last because split then returns a list. Your lower and strip, all these things will return text only, right? So I'm going to say lower dot strip, okay, dot split. Okay, now if you run it, just want to make sure that it is reading. Now if I say take, okay, what do you get? Okay, so yeah, see the spaces are stripped, all these things. Now I want to say quit. Okay, quit. Okay, so this is how we have read the data. Now we have to make sure that we are performing right operation. Now, how many types of operations are there? We have insert, remove, display, and quit. We have 4, right? So how do you check? We have to check for ch, right? We have to check for ch, right? Now, your if ch of 0, if ch of 0 equal to insert, then certain action has to be done. Elif. Elif ch of 0 equal to insert remove. Remove, certain action has to be done. Elif ch of 0 equal to display. We need to do certain action. Then here we'll say elif ch of 0 equal to quit, do this. Else we'll put. Else invalid option, try again. Okay, so we have managed our quit.
Yeah.
Now let's do the display thing, right? So display, we can call this entire thing, right? We will copy and paste here. Anyway, display is not required because after every step we are doing display, right? After insert, this is part of loop. Every time you run it, you get a display. The
Yeah.
display as such is not required, but yeah, let's see. Just for fulfillment of menu option, we have display. Okay, now comes your insert and remove. So remove is anyway just one option here. So, this we can call it as uh, what is that? Remove. It's remove only, right? Yeah. So CDLL. Now to remove, we will have to say CDLL dot remove. Okay, but remove what? Now remove. Okay, your remove. So remove will be the second value of CH,
Mm-hmm.
right? Remove will be the second value of CH. So I'm going to say remove CH of 1, right? But this is a string, so we have to convert into integer, right?
Yeah.
Okay, so this is good. Now, we'll also make sure, okay, if this value is there or not, correct? We
Mm-hmm.
also have to make sure that this value is there, isn't it?
Yeah.
Now, how do we know that it is there? Right? Before you remove, two things, that value has to be there. Otherwise, there is no point of doing that. So what we'll do here, we'll write another function, okay, which will say def get node or something. Okay, get node will take data. So we'll write get node, and so okay. Now you see, now do you want to do on data or on index? Okay, that's what I was thinking. Okay, let's do it on index. Okay, and I mean, see, index means you look at the value only there, right? So let's actually do it on index, okay?
Mm-hmm.
Because like I want to remove first element, the third element, okay,
Mm-hmm.
like that. So instead of using data, because see here also we have taken as index only, right? Remove index. So let's do index, okay, and we'll come back to the function later. So here you say, okay, this one is your index, okay? So IDX equal to this one. Now first we'll compare if this value exists or not, okay? If this value doesn't exist, then no point of, okay, uh, calling it, right? So we will say uh, IDX node equal to your CDLL dot get node, right? And then you pass IDX. So this will give us the node, and if it is none, right? So if IDX node, okay, if IDX node is none, that means that value is index is not there. Then we can say print no such index cannot perform remove option, right? Now, if okay, if okay, so okay, it's cannot perform remove option, right? And after that, you can go to the beginning. Okay, you can say continue. Continue will take to the beginning. You can say continue. Okay, or you can leave it like this. Now, if I say continue, I don't have to give else. I can simply say remove. If condition is false. Continue means go back to the beginning of the program. That means go back to the beginning of menu. Okay. So otherwise, okay. So this is how we can remove the element. Okay. So great. So we have perform, quit, and remove, and display too. Now comes the challenging part, the insert here. Now insert again, you have how many types of insert? You have 1, 2, 3, 4 types of insert, right? And we have those before, after. Now, so after insert, we have to read the third member, right? Okay. So you have to read the third member and we have to see what it is. And based on the third member, you will be calling the function, right? Okay. So what I'll do here, if ch equal to insert, then now you say if ch of 2 equal to, if ch of 2 equal to, within insert, after pass elif ch of 2 equal to before, okay, pass elif ch of 2 equal to at. Okay, now at again has two part, begin and end. Okay, and if something else is else, print error, try again, something like that, and you say continue. Okay, let it go to the beginning. Okay, now again, if you is at, you will say if ch of 3, correct, 0, 1, 2, 3 equal to beginning, then perform certain thing, elif ch of 3 equal to, and perform certain thing, else same thing we'll use here, error, try again. Okay, we'll copy this as it is and we will put it here. Okay, so we have created all these. Now, this is good. Now we will data will be read anyways, right? So insert, okay, if it is insert, you have to create that node anyway, right?
Yeah.
So how do you say here? we'll call data or data you're using. So let's use value. You can use data because that's a different class altogether. Value equal to int of ch of 1, correct? So this will give us the data. So value is here. Now what? Now you have to create new node, right? So new node equal to node of data. We have already created value here. We have already created node here, right? Node class is there. So node is ready. Okay. Now the question is, where do you add this node? Right? That's the question. Right? Now what we'll do is we'll insert after. Okay. Now all these insert should have a node, right? Okay. Insert node, update node. Okay. Insert node. Okay. Whether it is an insert or whether it is before or whether it is after, this will have the value, isn't it? So this has to be added, appended. Okay. So here we will go and insert after, before, begin, end. Okay. So here we will call insert after and we'll say new node. Okay. Right. Makes sense? Hmm. Now why? Okay. So you have to call this object. Now why I'm wondering is CDL because it needs. Okay, for now, let's put like this. We'll come back and fix it once we have the function ready. Okay. CDLL dot insert before. Okay. Because we need to check the position also, right? Okay. Then we'll say CDLL dot insert begin. New node. Okay. CDLL dot insert end. New node. Okay, we'll come back to this. Okay, we'll see. Okay, we have if we have to add anything more. Let's first start building this. Okay, this should not have any error. It should work fine. Okay, I want to quit. Let's display and see. Okay, display. Okay, display has only display. Okay, fine. Let's quit it for now. Okay, let's start building each of these one by one. Okay, so first is get node. What should it do? So it takes index, fine. And here, let's say current node equal to your self dot first, right? So by default, you're at the first node. Now you have to go and iterate, okay? Because index is given, so we'll iterate through the index here. So we'll say for I in range, for I in range index, right? And for I in range index, see the index, we expect it to be what user has given, let's say 0 or 1 or 2. Okay, so we want to include up to index, right? So we'll say +1. Okay, so we want to go up to the index, so we'll say +1. Okay, now if you find this, okay, so earlier current is first, right? Now the current is going to be, okay, current
Mm.
is going to be um, current current is going to be current dot next,
Mhm.
right? Current is going to be current dot next. We are moving. Okay, how many times you have to move? Number of times you have index. Okay, now if you are moving, because it's a circular list, right? Okay, you will not end, you will not reach end. Remember, see, if I have to check how many index are there, okay, in linked list, if you have 10 lists, 10 nodes, you will reach last node, and then if you try to go next, you will go none, right? But here you will not have none. Why? Because it's circular. So if you say 10 times, it will keep on going to the first. So now if I go to the next, okay, and after going to the next, I reach first node itself. So if I say if current, okay, equal to first node itself,
Mhm.
that means you have reached to the beginning and you do not have the given index, right? Or
Yeah.
else when you are done, you can say return current, right? So it's like you're moving, and if you have reached to the first, you started from first, and again you have reached first, that means you have finished, right? And you do not have any more element in the list. Okay, so your index will return none. Index should return
Mm.
none, right? That's why index is returning none here. Okay, so far so good.
Mm.
Okay, now let's go to insert after, and then we will test it together. Okay, now
Okay.
in insert after, um, you have, okay, so see, insert after will take two values. One, your current node where you want to, not current node, but where you want to, after which you want to
Mhm.
add, right? So after what? So we'll say here after something, right? So we'll say before node or something like that. Before node, and this will be your new node. Okay, so it should give me before node and after node, new node. We'll go back and fix later. First, let's see how this will work. Okay,
Okay.
so we have this now. Um, your so before node, okay. So when you say new node, okay, so your new node dot previous is going to be before node, right?
Mhm.
And your new node dot next is going to be before node dot next, correct? So
Yeah.
whatever was at before node next should now go to the new node next, right? And then the new node, because since uh, okay, so now you have before node next, right? Before node next, new node is pointing to before node next. Since it's a doubly linked list, your before node next should also point to new node, isn't it? A priv. Before nodes next previous. Okay. That means before node next node's previous value should point to new node.
Yeah.
Right? Next previous. Okay, should point to new node, or this is same as new node. See, new node next is this one, right? So it's same as new node next. So new node next previous should be new node. So what we have done, we have added new node previous and we have added new node next. So new node is is okay. Now before node next should be new node, isn't it?
Yeah.
So before node next is should be new node, right? So 4 changes you have to make. So if I go back to so right now what we have seen you have a node here, you have a node here, okay, and you know this is okay, you have node here, this is connected to this, and this is connected to this. So if when I insert a node in between, so first I have to point this nodes, okay, this nodes next to this and previous to this. Okay, next will be this, previous will be this. And then this one have to break and point this one's next here, and have to break and point this next here. So 4 steps, 4 operations have to perform. This node's previous is this node's next is this. This node's previous is this node's next is this.
Yeah.
And then this node next should be this one, and this node's previous should be this node. 4 operations. So those 4 operations we have performed here. So I think we are ready. Okay, we are ready. Now we'll go back and call insert after and see if this is working. So for now we have only insert after, which is implemented. So insert after, right? Okay, insert after, but insert after which node, right? So if you see here, insert data after index. So I'm talking about index here. Index node, okay. So this is not index, this is basically your, this is the value, right? So it is int of 0, 1, 2, 3, right? This is 3. Okay. Now, obviously, when you run it, and we do not have any index now, right? So if I say insert data, so I'll say 5 after 1. Okay. Int object has, okay, sorry. Line number 62 should give error. I know 62. Okay. No, wait. Now let's come back and fix this. So this is your index is always about the position, isn't it? Okay. is about position. So we need to get the element at the given position. So how do you get the element at given position? We have to call get uh, uh, get node, right?
Yeah.
Get node will give us the element, right? So
Mm-hmm.
you have to say here, okay, data equal to cdll dot get node, and then here you pass the index value, and data should be passed to index after,
Mm-hmm.
right? So now if you run it now, okay, I'll say data, okay, so I'll say data 5 index, let's say I give 2. So what happens? Okay, there's a none object, right? So that's why none cannot have next. Now if I say here 5 at 0 0, okay, same problem. Why? Because now in line 62, wait, no, no, wait, hold on, something is wrong here. What are we doing at get node here? Remove. So we are passing idx only, right? Int of this one only we are passing. Get node int of ch of 3 is what? 0 1 2 3, correct?
Mm-hmm.
Okay. Okay, so we have not handled this none, right? We have to handle this none, and then only we'll say that element not found, right?
Yeah.
So that's why this error here is assuming. So we'll say here position or some a value or something. Now let's say we say this. Now we will do, okay, sorry, data, right?
Mm-hmm.
Now we will say here, okay, if data is none, print given index doesn't exist, else perform this. Now when you run it, if I say insert data 5 at index 0,
Mm-hmm.
line number 15 is what? Line number 15 is current equal to current next. Okay. Index current equal to, okay, because this is not there, right? If self dot first and in range 0 plus 1, if I do index, okay, I think we should, it was going out of index, I guess. Let's try this 5 6 0 here. Okay, so given index does not exist, it does not even have one value, right? And we were going 0 plus 1, so up to second value, like, so first value doesn't exist, isn't it?
Yeah.
There's no value. So yeah, this is how you get this.
Mm-hmm.
Okay, so so it's saying current range of 0, right? But there is no element here. So if there's no element, even 0 will not be there. So it
Mm-hmm.
will return none to us. Okay. So okay. So with that, I think our insert after is almost done. We'll test it once we have any element. Okay.
Okay.
Now we'll add about add at the begin or the end. Both should work. Okay. Where is begin? Okay, this is beginning. Okay. Now, how do you handle beginning? Um, so to add this to begin, right? We don't have to give new value, right? Begin and end. This should be enough. It should work with just new node here. Let's go back and build the logic here. Insert begin. Now, insert begin. Okay. So our first node is pointing to the null, right? So that first null, this thing should not point to the null now. So I'm going to say self dot, okay, self dot, okay, self dot, it's not self dot, okay. See now, see if there is empty, okay, then you can say the first equal to node if it is empty. If it is not empty, then what do we do? Okay, so we'll say this. If self dot first is none. If self dot first is none, that means we are looking at the first value. Okay, then what should we do? And if it is not the first member, then what we should do? If it is not first member, then we're talking about beginning, right? We're talking about beginning. So beginning, in fact, whether you add at the beginning or the end, it's the same thing, right? I mean, so we can club it later, begin and end. Now insert begin, okay. If it is not first, then okay. Okay, let's come back to it because see, if it is first, it's easy. What should we do? We should say self dot first equal to node, right? First itself is node, and then node dot next. Okay. So because see the in double linked list, okay, if you have one value, it should point to itself. Okay, it should point to itself because only one, right? So if only one, then it will come back to itself. So self dot next is also node, and node dot previous is also node. Okay, this is good when you have only one value. Okay, we'll come back when you have more values. Similarly, at the end, if you look at, okay, if you look at the end, we'll have to check again. What does it have any element or not? Does it have any element or not? So I'll have to repeat it. Okay, for end. Now instead of repeating it, okay, can I reuse the code? Okay, can I reuse the code? So, so how do I reuse the code?
You can, I don't know.
Okay, let it be. Okay, for now we'll come back and once because you know the challenge here is if you're adding at the beginning, right? Now, if you're adding at the beginning and you have more elements, it is same as adding after something. What after something? What you are adding after the end, isn't it? So if
Yeah.
I can find the end index, it is same as insert after. Yes or no? Okay, insert after, does that, okay, this new node will be called first. That's it. Okay, so let's see step by step. Okay, so far it's good, right?
Yeah.
Okay, so far it's good, right? So, okay, now we have added some logic in both after, at the begin, at the end. Okay, now let's come back to insert before and we'll see, okay, if everything makes sense or not. So this one also needs your before node, right? So insert before what? Before this. Now for before, okay, now see, let's go back to paint for a second. So what we just did here is adding after, isn't it? We added after this. Now let's say if I'm saying you have this node and this node, and I'm telling you to add before this, correct? Now if
Yeah.
I'm telling you to add before this, is it not same as adding after this?
Yeah.
Correct? It is same as adding after this, isn't it?
Mm-hmm.
So what I will do, I will go here, okay, and in insert before, I will say insert after, self dot insert after. Okay, insert after what? Okay, so of course you have first self, then um, your this is going to be before node dot previous. Correct? So
Yeah.
if I'm saying after before this one, that means after, add after previous of that node.
Yeah.
That's it,
Yeah.
right?
Right. Yeah.
Okay. Now, come back here. Insert at the beginning once you do. Okay. So we added, now this first should belong to this one. Which one? First, if none is first equal to node. Okay, this is correct. Okay, if first equal to none, else, okay, else, um, let's see this. You are adding at the beginning, correct? So if you're adding at the beginning, if it is none, then we are doing self equal to and all these things, fine. But if there is a value, okay, that means first has a value, right? So is it not same as self dot insert after, okay, insert after, okay, self dot previous, in fact self dot, I mean self dot first dot previous, okay. So I'm saying to add at the beginning, okay. So beginning, you already have self right now, so self, not the previous, sorry, yes, previous only. Self's previous is the, again, let's go back to paint here. So you have nodes here. nodes here. Let's say 3 nodes you have. Currently, this is your first node. Okay. So next is this one, right? But this previous is this one, correct? Right? Now, I'm saying add at the beginning. That means I'm to add here somewhere. So to add at the beginning, should I, it's same as like breaking this link and connecting to this, right? It is like as if you are adding before this one, or you're adding after this one. Since we have logic only implemented for after, right? That means first previous is the last one. I want to add after this. Automatically, it is like adding at the beginning.
Yeah.
Right? So I want to add after first previous. First previous is the last node. So it's same as adding this at after first previous. Okay, instead of see, if we had implemented logic for before, see, one logic is enough to handle all the three. If we had implemented before, then we would have said insert before first. But since we have implemented after logic, we are saying, okay, add after first previous. First previous is the last node. So add after last node. Okay, so that's how we will add here, saying insert after first dot previous. So insert begin, story is done. Insert end. Okay, and there's no element as such. Okay, then it's same as adding first. Okay, so what I can say here is, if none, then call self dot insert begin, right? Then node, correct?
Yeah.
Else, if there are element and I want to add at the end. So it is when I'm adding at the end, okay, adding at the end is also same as, okay, I'm saying add. So it is same as adding after last one, isn't it? Right?
Yeah.
So in my, I think it is same as doing at the beginning, isn't it?
Yeah.
Only the problem, yes. See, the difference is your first see, it is same as insert at the end. Okay. Only difference is, okay, in begin, you have to perform self first equal to node. Self first is node. This is what extra step you have to perform. This extra step you don't have to perform when adding at the end. So it would make more sense if we add this logic to insert at the end. Okay. Insert at the end and not giving first equal to node. Okay, see, it is empty. So empty first will be node only. But in else, okay, we are not doing. So here what I'll do, I will call self dot insert at the end. Okay, same as inserting at the end. And I'll put an extra step here saying what? So adding at the first is same as adding at the last. Circular.
Yeah.
Only thing is, when you add at the first should point to the new first.
Yeah.
Otherwise, it's exactly same as adding at the end. And if there is no element, then adding at the first is same as adding at the last, exactly same. So that's why we are setting first equal to node. Okay. Now,
Yeah.
I think Okay, remove we have not done yet. Display also we have not done yet. Can you
Yeah.
try remove and display today? Okay.
Okay, sir.
Yeah, and otherwise tomorrow we'll complete it. Now
Okay.
here I think, okay, maybe there could be some small error, but logically I think we have got it, isn't it?
Yeah.
So what we are doing insert before, after, at the end, at the beginning.
Mm-hmm.
At the big, okay, so we did logic for after. Okay, so after, simple. Okay,
Mm-hmm.
after we're saying that, okay, new node, previous should be the before node because we are passing before node as well, and new node next should be before node's next.
Mm-hmm.
Then you are saying new node next dot previous. Okay, so new node next is the next one. That previous has to be new node. Okay, for chain, you are doing it. Now insert before is like you are going one step backward and you are using insert after. We are going one step backward, right? And then it becomes same as insert after. Insert beginning is same as insert end, just that new node should be pointing to the first.
Okay.
Now insert at the end, okay, if it is blank, of course you have to add, okay, and if it is not blank, then it is like saying add me after the last node. After first previous is last node.
Mm-hmm.
Circular list. So first previous is last node. So it is same as adding after last one,
Yeah.
right?
Mm-hmm.
So this is how you will end up getting the values. Okay. So yes, we'll stop here. Okay. Tomorrow we will build the for remove and display, and then we can test the entire code.
Okay, sir.
Okay.